Hey guys, welcome to my channel and I'm back again with another really interesting coding interview question video this time. So here guys, we are going to solve question number 380, insert, delete, get random order of one problem from Leetcode, which is the medium level problem. So without taking any time further, let's get started with the problem statement. So basically guys, you can see the problem statement says that we need to implement a randomized set class. And what this randomized set class does is that it basically initializes a data structure, which is sort of a set type of object, and there are certain operations that you can perform in that object. So you can do insert, remove, get random. If you do insert, it inserts an element into the set. If that value is already present, then it returns false, but if the value is not present, it inserts the value into the set and it returns true. Second operation is remove. So if basically if you call remove, it is going to remove the value from the set if the value is present, and if it is successful in removing it, it will return true, but if the item was not present, it's going to return false. And finally we have got the get random method, which basically returns a random element from the current set of elements. Okay, and each element must have the same probability of being returned. Now the catch here is that we must implement all these functions in such a way that each function works in an average of order of 1 time complexity. So that is basically the challenge that is given to us. If you see the example, it is very straightforward. We are just given these operations. So the first operation is randomized set, where we initialize the set, then we insert some element in it, then we remove some element from it, then we insert, we remove, and we do all these things and we call get random to finally get some element, right? So this randomized set is just going to initialize, then we insert one, then we remove two, then we insert two, then we check a random element, and basically like that. And the output is so obviously if you are initializing a set, we are not getting anything, so that will return null. But other than that, if you are able to insert something or remove something, you will get a boolean value. And if you are getting a random element, you will get an integer value from the set. Okay, so constraints are also that the value goes from 2 to the power 31 to 2 to the power 31 minus 1. At most 2 into 10 raised to power 5 calls will be made to insert, remove and get random. So we can see that a lot many calls can be made to these two. So we have to keep the time complexity the minimum, and there will be at least one element in the data structure when the get random is called. Okay, so get random will never be called on a data structure when there are no elements present. Okay, so now that we know about the problem statement, guys, let's try to understand how we can solve this problem. Okay, so here you can see, guys, that one way is that we have got a set, right? So let's say this is our set, right, and we have got these two elements in it. Now if I want to simply insert an element, that is pretty straightforward, guys, because if I want to insert an element, I can actually just do an order of one operation. So let's say after 1 and 2, so let's say if my set has 1 and 2, and if I make a sort of a list, in order of one operation only, I can add another element called as 3, right? So let's say if this was a list, it would have been, it would have been an easier task, right? However, if you want to remove an element, right? So let's say if I want to remove an element from the list, let's say if I want to remove 2, right? So in that situation, if I want to remove 2, I have to actually traverse all the elements, right? So I have to go from 1 to 2 to 3 and then find out which element I want to delete and finally remove that element, right? So that will be an order of n operation, but I want to make it order of one operation, guys, right? So that is where the problem lies. So we have to create the set in such a way so that if you are inserting an element or if you are removing an element, both should be order of n. Okay, so let's delete all this and let's try to understand it in a different way. So what we are going to do, guys, to solve this problem, we are going to actually create our data structure with two small data structures. Okay, so what we are going to do is if we have randomized set, we are first going to have a list of elements. Okay, so let's say we have got 1, 2 and 3 and 4. This is my list, and for same elements I am also going to have a dictionary. Okay, this is going to be my dictionary, where in front of each element, so let's say this is my element, that will be the key, and the value will be the index of the element. So let's say the index of 1 is 0, and then the index of 2 is 1, and index of 3 is actually 2, right? So I am going to create a dictionary where I will actually maintain the element as a key and the position of the element as its index. So now let's say if you want to insert element, it is an order of one operation to insert an element into the list, right? So if I want to insert 4, I can easily insert 4. Now if I want to insert 4 here, I can easily do 4 colon 3 and close my dictionary, and that will be it, right? Here's my dictionary, that's complete. Insert is done. And this is all order of 1, right? Now if I want to remove an element, so if I want to delete an element, in that situation what I'm going to do is I am going to find out which element I want to delete. So let's say I want to delete element number 2. So this is the element I want to delete. Now it is order of one operation for me to find out what is the index of that element in the list. Okay, so if I want to do simply, if I want to do my dictionary, sorry about that, if I want to do my dictionary dot get and then I write 2, this is going to give me 1, right? So in order of one operation I actually found which index of the list I want to actually delete. Now once I found the index, guys, I can just go to my list at that particular index. So let's say this is my list. So at index number 1, I have the element that I want to delete. And what I'm going to do is I am going to just simply replace this element and I am going to equate it to the last element. So what is the last element in my list? So let's say if this is Python, I can just make it the last element. So in that case, simply this 2, or let's say this 2, will actually be deleted from here and it will be replaced by 4. So now you have your list 1, 4, 3 and 4, and because I replaced the last element, I can just simply at the end delete from my dictionary and also delete the last element in the list. Okay, so last element in the list and delete the element from the dictionary. So I am able to remove it from here also, and I remove the last element. So eventually my list will become equals to 1, 4 and 3. And before I remove it from the dictionary, and when I remove it from the dictionary, I also update the dictionary so that my last element's index now becomes equals to the index that I updated. So my dictionary will become equals to 1, 0, and then 2, 1 is deleted. So and then 3, 2 is my index, and then 4 is now updated to index number 1. That becomes my dictionary. So I basically, in order of one operation, I was able to achieve this task. Only thing I did was I maintained a list and I maintained a dictionary where I simply, in the dictionary I am storing the elements and their indexes, and in the list I am actually storing the order of the elements. So whenever I delete an element from the dictionary, I take its index, I put its index in the list, I replace it with the last element, and finally I delete the last element, and that gives me my answer. Okay, now let's talk about the last operation, which is the get random operation. So if we talk about the get random operation, guys, then basically we can assume that all the random operation libraries that we have in Python or Java are order of one operation only, and if we just give them the whole list of elements, they are going to give us our answer in order of 1 time complexity. So we are not going to actually bother about implementing a whole lot of things with the get random method. Okay, now that we know how we can solve this problem, guys, let's jump into the implementation, which is actually very easier than it looks. First thing first, I am just going to initialize my dictionary, and I am just going to initialize my list. So this is my dictionary, this is my list. Finally, what I'm going to do is I'm going to start inserting the elements. So if the value is in my dictionary, it means that I don't have to insert anything, I can just return false. In case the value is not in my dictionary, then I am going to place it into the dictionary, and when I am placing it into the dictionary, its index in the list is going to be the length of the list itself, right? Because it is going to be inserted in the end of the list. And finally I am going to append that value into my list, and when I am doing that, I will be returning true because I was successfully inserting an element. Finally comes the remove part, and remove part is just how I explained it to you guys. We are going to first find out what is the index of the element in the dictionary, but before that we just check if the element is in the dictionary or not. So if self.get val is not equals to none, if the value is not equal to none, that means the map has the value, dictionary has the value. In that case, we will find out the index of that value in the dictionary. So self.dict.val, that becomes my index. Then I will also find out what is the last element of my list, and the last element of my list is going to be self.list -1. And then what I am going to do is I am going to list at index idx, I am going to replace that value with the last element of the list. Okay, so simply self.list idx is equals to the last element, and then I can easily delete my last element. But before I delete my last element, I will make sure that my dictionary who has the last element must be now updated to the new index. Okay, because dictionary has got the index of each and every element, so now that I have replaced the index idx with the last element, I must update my dictionary as well. And now I am able to pop the last element out of my dictionary, which is again an order of 1 operation. Then I will also remove that element from my dictionary itself. So self.dict val and delete, and then I will return true. However, if that is not the case, that means the value is not present in the dictionary at all, I will simply return false. Now comes the GetRandom method. So for GetRandom method, guys, we are going to use the Python's random library, which we can actually import above. So import random, and then you can just do random.choice. So GetRandom is going to be random.choice, and just pass the self.list here. Okay, and return that value. Let's run this code, guys. Let's see if this has any error or not. Okay, then particularly there is one error in here because self.list.append, it's not self.append. Okay, and you can see my case 1 is accepted. Let's submit it to see if all the other cases are accepted or not. And there you go, guys. You can see all the other test cases pass as well. So that was it, guys. With this approach, we are able to solve this problem in order of 1 time complexity, and we are also passing all our test cases. So I hope you like the solution, guys. I hope it made your coding practice a little bit better. If you did like this problem, guys, then please do not forget to like this video and share this video with your friends. If you have any questions, comments, suggestions, feedback for me, please do write down in the comment section below, so I would be happy to address them. And also, guys, in the end, if you have not yet subscribed to my channel, please do subscribe and hit the bell icon for future notifications of more such programming and coding related videos. I'll see you guys in the next video, guys. Until then, take care and bye bye.